This is the technology that's transformative, so we need to master it in-house. So we have teams, that are in-house that work with the lines of businesses and to really understand, the end user and the customer pain points, rather than rely on, vendors who might pitch lots of use cases that have been successful elsewhere. Now, okay, it's not that we close our ears and eyes to anything that they say. We certainly pay attention to the market, but we really want them to be developed in-house that are relevant to our context.
If you're wondering what it actually takes to deploy AI at massive scale, then today's episode is for you. I spoke to the VP of AI offers at Schneider Electric, who have 150,000 people and 35 billion in revenue. You're going to hear about the immense value that applied AI and machine learning creates in the energy sector, how AI can support net zero emissions goals and address climate challenges, why LLMs are actually not intelligent and simply regurgitate information from dark corners of the internet, the difference between traditional software focused on a single version of truth and the variability that comes with LLMs, a framework for evaluating AI vendors and investments based on business case first. There's a ton of stuff in here for anyone interested in applying AI at scale or understanding how to sell into businesses at that scale. You're in for a good one with Sreedhar Sistu, who is VP of AI offers at Schneider Electric. Hey, and thanks for listening to the Chief AI Officer. Today, I'm really excited to bring you Sreedhar Sistu, who is the VP of AI offers at Schneider Electric. Sreedhar, thanks so much for coming on the show.
Thank you, Ben. Glad to be here.
Yeah, before we get started into all the things that you're doing, can you give our audience just a quick overview of Schneider Electric and kind of the scale that you're operating at?
Yeah, absolutely. So Schneider Electric is a global energy management company. So we provide solutions to manage electricity at various levels. Whether you're talking about at the distribution level, the electricity that comes to your house, or whether it is something that you manage in critical buildings, hospitals, schools, or whether it is in factories, where you need high quality power. And in addition to this, we also provide lots of automation solutions, the ones that automate factory lines like, PLCs, drives, etc. And one of the important areas that we contribute to, now, and also the fastest growing areas, is in data centers. So data centers are like, the, factories of 21st century. And they need lots of electricity, cooling, and, we provide solutions for that. It's a global company with about, to give you the size and scale, about 150,000 employees, give or take, present in almost, all the larger countries, in the world. Company has been around for over 165 years, so not a new kid on the block. And, we have presence in, hubs. We have hubs in North America, Europe, India, China, and yeah, it's a highly globally distributed company addressing some of the very important challenges, of this century.
Yeah, I think 150,000 employees and something like 35 billion in revenue relatively recently. So it's definitely, you're overseeing AI at scale, which is exactly what we're going to get into today. More personally, for you, what was kind of that first aha moment and how did it end up shaping your career?
It's kind of funny, and when I tell people that I work on AI at scale, and when I tell people about the story of my first introduction to AI, it almost sounds like a made up story. In fact, my first encounter with AI was when I was in college in India, and that's when I just started learning programming, and I was really enamored with the idea of expert systems that I read in a book at the time. So my first programming project was using Prolog, which was a language popular in building expert systems. Expert systems never scaled as a technology, but that is really first time where I cut my teeth into doing something called AI. So this is quite a while ago, and then I was I went on to study, math and statistics, which are, behind the, a lot of machine learning techniques today. So it started very early on in the career for me. I took, obviously a detour into enterprise software, focusing on the industrial side, but then, I got back into AI and, I think we are at a great, moment in history, for this technology to flourish and, help humanity.
I love that historical context because I think it's DARPA that has kind of those three waves of AI in terms of small expert systems like logic systems, then the statistical wave, which is I'd say we're very much in right now, and then the next wave in terms of more hybrid kind of cognitive systems that will combine the best of both worlds, hopefully. So yeah, it's sometimes you lose sight of those things when there's so much hype around statistical approaches today and large language models. You mentioned starting, you were in software development in industrial kind of settings. What convinced you that AI was going to have a transformative impact in industrial automation and energy management?
Just to kind of give a bit more on the background. So I know I worked at the enterprise software that was helping the engineers and designers build products. I think one of the challenges that I saw come during that time is most of the software is really about having a single version of truth, right? It is I put something inside and I know I can get it back, and then maybe I have a small workflow that people can review it. I mean, this is at the core of all of enterprise software, right? And it's it sounds simple, but it has tremendous value, and it has helped companies achieve the levels of efficiency that they have not seen since Second World War. Now, I think what convinced me is that there is a natural limit to how much you can do by sharing the single version of truth. What people need is really the assistant augmentation, the type of things that machines that are good at, that can help humans. And AI is really, the one that, was going to help get out to the next wave of productivity. And moreover, what we have seen is, there has been a confluence of things that came. I mean, everyone knows that, okay, we had, internet, and then, we had mobile computing, then cloud computing, and, then that resulted in a lot of data. And suddenly we found that, okay, to build AI systems, we can use cloud and data and then, build these really useful systems. When I saw that, of course, I had the interest in AI from the, get-go, but this is a point of inflection where you can see it really, becoming mainstream, no longer a research project, something that can, help the enterprise users. And the second side is energy and automation. At the heart, I'm really focused on the industrial side. I mean, I love factories, and I think this is something in modern 21st century we tend to forget. All the things that needs to happen to help us do things day to day, whether it is having great products or transportation or comfort in our house. And I see this as an area that can be helped by AI in a significant way. So yeah, so it's both the maturity of technology and the potential to apply the technology in an area, that is really important for society.
Yeah, I think industrial manufacturing and automation and kind of energy management is such a great example of an industry where applied AI kind of machine learning has been providing immense value for so long, right? Preceding all of the hype that we see today. You mentioned single source of truth, right? I think that's very interesting to push on a little bit because traditional enterprise software systems, like a lot of traditional programming, is very deterministic, very procedural, right? It's like you have a definite deterministic outcome based on running that. You could run the process a billion times and it's always going to have the same outcome. What we're seeing with LLMs and neural networks is not that, right? Inherently unpredictable. Mm-hmm. How does that change? Like, is that affecting how you're thinking about building these systems?
It's a great observation, and this is something that we kind of started to think about when we built some processes and tools, and we'll talk about that later on, working on AI at scale. So one of the fundamental changes in thinking that has to happen is the outcomes are not guaranteed. So when you are working on a data science project, a machine learning model, it is not guaranteed that you are going to get the level of outcome that you wanted. You may get a little bit less, you may get a little bit more, and then maybe you can compensate it with something else. And we have to be tolerant to that level of uncertainty, which is, you cannot build a process where that the moment I touch something that it is going to reach the end of the funnel, completion of the project in a certain period of time, because there is inherent uncertainty. But at the same time, inherent uncertainty does not mean that you don't do anything, you just let things fail. You have to have a process in place that deals with uncertainty in an effective way, whether it is having stage gates, whether it is having, assessments, and also a lot of education to people. There has been lots of papers written about how humans are not really wired to deal with uncertainty. You put like percentage errors or, tolerances. It's, cognitively very difficult to understand. So we really have to train people to accept that, there is going to be uncertainty both in the process that gets you there, and even once you reach there, the outcomes that you expect are going to be, somewhat probabilistic. So it really changed our way in designing the process and educating the users about how to use this technology.
And as you educate those users, is there, what do you think is the biggest misconception that people have when it comes to AI, and why do you think that persists?
So I think with technology like AI, I think one of the biggest challenges that we contend with is the heightened expectations. LLMs are really the drivers for this, right? So LLMs have this ability to communicate with you in a natural way, and I can produce really intelligent text, which is, in some sense, a regurgitation of something that existed in some deep corner on the internet, but it sounds novel to you as a user. So it it is extremely good at creating this illusion of a really intelligent technology behind that. I mean, this by no means to reduce the importance or the difficulty in building a large language model. I mean, these are enormously complex products. These are the things that are also very useful to do certain things, but it leaves you an illusion that this can do anything, because I can ask, 5 questions like I would ask, you, Ben, and then, I get answer. Then I start assuming, oh, you know what, maybe this can do my travel planning. This can also do math. This can also, so there is heightened expectations that people have about AI, which means that you will never be able to live up to, the measures that people have. So I think calibrating the capabilities of AI, where it is useful, where it is not. Serious users know that. I mean, people who have spent enough time with I don't know, LLMs conversing know that after some time, things kind of start to go adrift, right? People who use image generators, I mean, I have used a lot of them, and it's merely good, but you look closely, there is an imperfection somewhere. There is something that should not be there. And getting rid of that takes a lot of time, right? So, and are they getting better? Absolutely. I mean, when GPT-4o got released, I was testing it. It could read my handwriting very well. I mean, that was mind blowing for me. I have very bad handwriting, so that it was able to interpret that. So, in that sense, I think the biggest misconception is the heightened, expectations, and the reality is we have to put in place what technologies like LLMs can do, and then there are also a whole host of other techniques that are important, useful, that have a place in that. So, but to me, it's really that.
Yeah, you said regurgitate information somewhere deep in the internet. We always forget. It's easy to perceive it as intelligence, right? I think a lot of people that I speak to on this show that have been practitioners in the field for a long time would say that this is absolutely not intelligence as we really think about it. It is just a vector database, but it's creating the illusion of intelligence, I think, is also something that you said, right? Which is very interesting because it's communicating in our language, and that has inherent risks too, right? Because it takes an expert to also know, wait a minute, this is actually wrong. This is a hallucination, or like this is just pulled two things together that should not be together. So it's going to be an interesting way, and I like that you're focused on use case first. Of this is one of many techniques. Where is it? Where can it fit in a valuable way? To you right now, which use case is most overrated and which is kind of flying under the radar, maybe from the perspective of industrial automation and energy?
So I'll talk about the second one that I think to me really interesting is something that is very close to me, which is about energy optimizations. I mean, the energy ecosystem is a very complex one. And of course, we're not going to solve all the problems with just one AI model. But as you know, energy is one of the I guess an area under scrutiny right now for two reasons. Number one, there is increasing energy demands that are coming up, and especially with the average consumption growing up everywhere in the world, there is going to be growing demands. And there is also a push to use renewables, because there is only so much that we can do through fossil fuels. Fossil fuels have an important role to play. They will continue to be part of the mix, but we need to augment them with renewables, and then make people transition, to using this in a much more efficient way. So in all these places, there are several problems that are quite complex to solve. For example, if you take an area that we work very closely in, something called microgrids, it's an energy system, right? You have a collection of things. You may have a solar PV, in your facility that is producing energy, but that is intermittent. So you need to be able to store it effectively. So you need like an online storage system. You may have a backup generator, right? And then you have the demand, whether it is the demand in the building for HVAC system, lighting, or as all the essentials that are required. And which, by the way, I mean, buildings are a very large source of consumption in the world, right? Almost 50%. So now, to orchestrate all of this, you need to know, first of all, a little bit about future demand, right? So you need to forecast, and forecasting requires, we've used the traditional techniques, in forecasting. It's not a new area, but we know that with machine learning, we can get much better forecasts than what we were able to do with the traditional, econometrics. And then you have to make some real-time decisions about, which energy source to use. The one that you use, produced in your solar panels, or something that is coming from the grid, or you have to get the backup generator. So all these decisions are very complex to make, right? And if I scale it down even to home level, where you might have, let's say, an electric car sitting in your garage. Okay, you may have an electric water heater, and how do you optimize, the energy so that you are not hitting, or you're not introducing peak demand, on the energy system. For those in the industry, they know that, for example, on the East Coast, 6 p.m. is like the peak demand time. People come home, they turn on lights, they turn on everything, and then all the utility companies are ready for that. They have to run some peaker plants. So the thing that is not super visible, but it is really important, is using artificial intelligence to manage this peak load, to manage the optimal mix of energy while maintaining the comfort. Right? I think this is the one that to me is one of the most important use cases of applying technology to solve real world problems. At least from my perspective, I'm sure there are plenty of others. Now you talked about the overrated problem. So I don't want to again get on anything to complain about LLMs or anything, but I think of the use cases that use generative AI, whether it is in communication, summarizing, translation, etc. I think are quite useful, but again, it is easy to get into the trap of thinking that they are going to become really smart without having the right amount of knowledge underneath. Otherwise, it can sound very superficial, nice. It's like a conversation you would have with a stranger where you don't go into depth. You can have a nice conversation, but you did not get anything in the end. So same thing, having a good chatbot that can talk to you does not mean, you get an in-depth technical answer, which requires a knowledge management behind it.
That's part of why everyone is, rushing to build their own retrieval augmented generation systems,
Yeah.
grounding it in some of that knowledge. But at the end of the day, it still is limited just by design. But I love your example of energy management because that really touches to the heart of something so fundamental that everyone is experiencing. Me personally, I know in New York, there's not only is there kind of management of peak demand, but there's also kind of incentivizing the use of energy in kind of non-peak times, or like the way that you're paying for it. There's almost like there's a lot of AI being applied to the pricing of that as well, and not just the management of the energy.
And by the way, just to double down on that, I mean, today in most places, especially for residential, there is not a multi-tiered pricing. Commercial, facilities do have multi-tiered pricing from utilities, and other parts of the world, this variable tariff is a common phenomenon, right? I mean, it's just a fact of life, and I think we will start to see that in US, and be ready for that. So it's not only for the good of the environment, but it's good for your wallet.
And within Schneider Electric, as you're thinking about all these different use cases and applications of AI, how are you prioritizing what you're investing in?
Great question. I mean, this is one of the toughest acts that you can do or you have to do, because at the outset everything looks exciting, right? And for people who are like from a technical background or engineering background like I am, you get excited about lots of things that you want to do. So it is really important to look at the use case and understand what it is for. As a company, like Schneider, we are practitioners. We use AI in everything, but we are not the ones who are building AI, right? I mean, there are companies that specialize in that. And our intent is to say that look at AI as a tool technology that is going to help solve a problem. So we first want to understand the problem. So we call them as starting with use case, and then there is another side of it, which is I know the use case, but is it really the one that's going to give us the biggest bang for buck, right? And so that's what most people go with, as from business case to, or from building a business case, from use case to business case, right? Now, one of the real world challenges in doing these business cases is sometimes there can be a resistance in building these business cases because these are hard, and then there is uncertainty because you are thinking about future. Or in some cases, no, let us first prove technology works and then we build business case. So the approach we try to take is assume technology works, assume that it is solved problem. Okay, what can we do to move the needle? From a business standpoint, whether it is in terms of the products that we can sell or how we service our customers, etc. And if we think there is a strong enough value, and in the value also, you put some, general tolerance, for errors in that, right? I mean, you're forecasting future. So you at least should have a hypothesis on what the value is going to be. I don't need everyone to be precisely defining, to the dollars and cents, but you have to have the hypothesis, you have to have the magnitude of the impact. And to me, those are the things, that we take into consideration for prioritization. Of course, it is not always a simple rank ordered list of, okay, business value, this, below that, it doesn't. Because then we have to think of, what is the, importance for this, whether in terms of ease of adoption or what people might want, or in some cases, maybe this is really going to open doors for other things. Right? There are some tactical things that we do, but by and large, the main criteria is that assume technology is there to solve the problem. What is the business case? What is your hypothesis that we can evaluate it after?
Yeah, and you mentioned often you're not building AI, so I assume you're also working with vendors across those different spaces, right? Are they involved in that business case formulation? Like, how much do you trust a vendor coming to you with a business case? How do you evaluate a vendor when you're thinking about those applications?
We are quite fortunate at Schneider Electric in having a strong commitment, from our management, from all the way to our excom, to invest in these AI capabilities. We took the approach that this is not just good enough to, get something from someone and then use it, as I would do, like, I don't know, paper products or, office supplies. This is the technology that's transformative, so we need to master it in-house. So we have teams, that are in-house that work with the lines of businesses and to really understand, the end user and the customer pain points, rather than rely on, vendors who might pitch lots of use cases that have been successful elsewhere. Now, okay, it's not that we close our ears and eyes to anything that they say. We certainly pay attention to the market, but we really want them to be developed in-house that are relevant to our context. Now, there are things that we learn from them because in areas where we are not the experts, like if they have a new way to improve accounts payable or improve our HR processes or something in supply chain, we are obviously open to hearing the proposals from them, but I want to be sure that it's grounded in the reality of what happened.
So is it fair to say that when you're thinking about technology that is kind of core to your product and service offering, you aim for doing that in-house, and then when it's something that's more maybe operational, kind of like efficiency related like that, you would be willing to go more with a vendor?
Yeah, I think you put it well. So we certainly make that kind of a trade-off, saying that what is this worth, and if it is something that we are products, we absolutely want to retain the IP and the skills in house. And also, it's really about mastering. I mean, we are not the ones who have mastered the HR practices, for all large companies. There are vendors who have done that, and I'm sure we can learn from them better.
Yeah, don't get distracted, remain focused on the core, value that you're delivering your customers, which is, I think, a good thing for anyone to take as a guidance. You're operating at a massive scale, and we've talked about kind of the different techniques, but what does it actually take to move AI from, let's say you've made the business case, you've decided I'm going to invest in this. How do you go from the POC to full scale deployment, at a company the size of Schneider Electric?
We call that, AI at scale, inside our company. And then we started, building this process about, 2.5 years ago or so, and then we kind of been refining. So there are a few things that, come together to make this happen. So number one, I think it's, you need people. Okay, so we need to have the right kind of team, the right level of expertise. Building AI is not just data science. AI requires software engineering, AI requires data engineering, and AI requires product managers. So having the right kind of team is very important. So that's what we do. The second one is having a process in place. And you mentioned from POC to go to production. In fact, we really don't even, talk about like POC. We have a funnel process where we talk about, there are various stage gates. We say that we first explore an idea, and this, is we assess the technical feasibility and also the business hypothesis. If it passes the muster, then we go to the next stage. So we are actually making a stage gate decisions on the use cases at any time, with the freedom given, to the team that runs the use cases to stop at any time if any of the criteria are not met. And we do stop them because it is better to learn something and stop it at the beginning rather than to continue forever on something that sunk cost fallacy, right? I mean, I did so much that I just want to do 5% more to complete it. So I think it's having that kind of a process that is widely understood, that has consistent vocabulary, practices, etc., that we will follow. And then the third one to do this at scale is having a technology platform. You have to have a technology platform that allows it to run at scale. So in our case, what we decided was to build a technology platform in-house, of course, on top of vendor technologies. So, we are not building everything from scratch, but it is our platform that has, the workflows built in to take models from, initial development, testing, validation to all the way into production where we are able to monitor the models, the model drift, and then how to retrain, how to update them, etc. So these are really, the three key elements, people, process, and technology, and of course, having the right use cases, to go through.
Yeah, people, process, and technology. I think a lot can go into any of those buckets, but it's a good place to start. You've worked in the World Economic Forum on AI governance, and council. There's obviously a big balance between innovation, responsible deployment, ethics, governance. What have you learned having done so much work in that space?
Yeah, thank you for bringing that up. It was it's quite interesting to work with the World Economic Forum on number one, it's called the AI Governance Alliance. So they're really looking at application of AI at a sufficiently large scale. So a few things that and in no particular order of importance that stood out to me, and the learnings that I take is number one, this is in the context of the the industry 4.0. So we know that application of AI is going to be important in the evolution of the industries, of the future, and looking at it from a broader perspective. So it's not just about improving operational efficiency, but what it is also going to do for people, and the lots of emerging topics in terms of privacy, concerns on the on data, and then impact on employment, etc. The other thing that really stood out to me is you have the opportunity to hear from people from across the world. It's very easy to be in your own, small, narrow corridor or in your silo to think that, this is all there is to it. I got to speak with people, running some AI education programs in Azerbaijan. Okay, I know how it is working in South Africa. So I think it's very interesting that technology like AI has suddenly taken off, in every corner of the world, and hearing people their concerns, is quite enlightening. And lastly, because this is such an important technology, there is a lot of interest from everywhere in the world to regulate or to find some ways to manage it. Different countries are going to approach it differently. In the US, we've got different ways of approaching. There are some executive orders, and states are going to have their own bills. I think it also helps us to understand the regulatory environment in which this technology is going to operate. People, when they built up, initially just websites or social media companies, did not have to think too much about the regulatory environment. And I think that the AI, this is going to be coming very fast, and then we certainly have to be prepared for that.
Yeah, I had a VC on the show recently that talked specifically around not seeing regulation as a barrier to innovation, but seeing it as kind of the parameters for success, in the same way that you deal with employment law. That it's just one of the other things that these startups are going to have to navigate. You brought up the U.S. and different states. You've also testified to Congress on energy and AI, right? And what key messages do you think policymakers need to understand about AI generally, and then maybe specifically in terms of climate challenges?
So it was a great opportunity for me to, share, our views in front of, the congressional committee. To me, the important, aspects are, number one, this is a technology that, is going to help us solve some of the problems with, energy system that we have. So we need to really look at this as a net positive. Every technology, has some downsides that, we need to master and we need to control. But I believe this is net positive to solve its, the critical problems. Number two, I think we have to educate, communicate, a lot more on this technology. It's very easy for bad news to spread and compared to good news. So I think we have to make every effort to make this, much more, much easier to understand, by people that this is in a non-threatening way. And the last one is like every technology that is coming in, we have to have right policies and regulations in place to incentivize adoption of these technologies, be it VPPs, be it smart thermostats, new renewable energy technologies. I think we have to take all of that into account with, in combination with AI, to solve the problem.
Yeah, you mentioned a few specific technologies there. Do you have any other thoughts on what role AI can play in achieving net zero emission goals?
I look at in the energy system, AI playing role in at least in three broad categories. That's kind of how we think about it. Number one is really in reducing the energy footprint that is required. So this means that having an AI-enabled thermostat that can automatically adjust and reduces your footprint, even you having to do it. I mean, people are generally not particular about saving, a small amount of energy that does not have an impact at an individual level or a noticeable impact at an individual level, but the aggregate is a big thing, right? So reducing, really the energy footprint. The second one is optimizing the energy mix. What kind of energy and when is needed so that, we are not introducing the kind of demand. And the third one, which is actually a very large bucket, is enabling technologies, how to make sure that people can adopt these, more beneficial, technologies. An example here would be, a barrier to adoption of, installing an EV charger might be that you have to call an electrician, to take a look at your electrical panel to make an assessment. Okay. Today, using AI, in fact, we have a solution that we launched. You can take the picture of an electrical panel and then, it can recommend how much of load is remaining that, you can install an EV or not. So seems like a simple thing, but it can reduce friction in a big way. And we need many more such enabling technologies to adopt that. So that's kind of how we look at it.
I love that. Not just the kind of underlying technology, but also recognizing how much it's about getting people to adopt the tool as well as a way of maximizing impact. That's a very positive future, I think, when it comes to thinking about the impact it could have on climate in particular and net zero emissions. What excites you the most when you think about the future of AI, and what is most concerning?
I think the one that I'm super optimistic about, AI, not just because it's what I do day to day, but fundamentally, I think decades of research has culminated into something that's, as powerful as what we have today. And I think it's just beginning. So I'm very optimistic about the evolution in this technology in various domains, and it's really going to become, second nature to us. I mean, humans are very adaptable, to these technologies. The one that concerns me is overall. I think the communication and the people's opinions, whether it is heightened expectations or looking at it as a net negative, because of headlines that you see that can certainly slow progress or slow adoption, right? Even if the technology progresses. But I think in the end, we are sitting on a transformative technology, right now. And to me, it looks very bright, the future.
Well, that's good. As someone with a lot of experience in the field, that at least makes me feel better that you're optimistic. And to wrap up, do you have any strong opinions or beliefs about the field that you think many people in your field disagree with?
And talk about AI. To me, I think the misconceptions are that, technologies, I mean, there is a certain amount of magical thinking about how it works. I think there is a lot of process, discipline, rigor that is required to make, this technology work. It does not happen automatically. It's very tempting. And a lot of people, believe that in the end, this is going to be, DIY, everything can happen very easily. I tend to think that anything that is worthwhile requires a lot of hard work and discipline. That's why I see that every AI model that we build, every use case that we go through requires lots of, TLC and, blood, sweat, and tears. So.
Spoken like someone who has clearly been, integrating and operationalizing AI within a large company, because I think we're in a space now where, every young kid, every startup founder thinks they can build a wow demo overnight with LLMs, and they might realize that when you try to put that to work across 100,000 people in 150 countries, it might not work as
It's quite
expected.
public.
Yeah, yeah. And at the end of the day, you're right. The hard work will pay off for the use cases that really matter. Sreedhar, I love this conversation. I know that's all we have time for today. If anyone listening wants to follow your work and what you're doing, where should they go?
I think LinkedIn is the best place, that they can, find me, and anything that I share content-wise, usually there.
Thank you for coming on the show. I know I learned a lot about AI and energy in particular, and just what it takes to deploy at scale. So thank you for your time, and yeah, have a great rest of your day.
Thank you, Ben. Thanks for having me.